Now let's take a look at graphing parametric equations. This will look slightly different depending on what you use to do this. So slightly different for different models of graphing calculators, and then different again for Desmos, which is the tool that I like to use for these kinds of demos. Now, in some graphing calculators, when you go to graph a parametric equation, you might be able to split up into separate functions, say like x of t and y of t. And this won't be exactly right here, but on your graphing calculator, you may have to type in, let's say that x equals sine of t, y of t equals cosine of t. So Desmos has given me two different curves here. I have to do something slightly different in this setting, but that might be the way that your graphing calculator works. You should take a shot and see if that's is or is not how your graphing calculator handles parametric equations. For Desmos, we need to write a coordinate pair. So in this ordered pair, the first thing that I put in is the x coordinate of my moving point. The second thing that I put in is the y coordinate. So I said x is sine of t, y is cosine of t. A little bit opposite how we usually work, but that's fine. And then Desmos will usually assume that I only want values of t starting at 0 and going up to 1. I'll tell Desmos I actually want to start at 0 and go up to 2 times pi. So I get this circle. Now that's not so strange to see. My x and y values are the sine and cosine function. But I picked this formula specifically because when I think about my moving point, so here I will put in the same formula, but I want a fixed value for my parameter. So I'm going to have a slider a, starting at 0, going up to 2 times pi. So here is my moving point in blue. And what happens to that moving point as a increases? It traces the circle in the clockwise direction. So a equals 0 is the coordinate 0, 1. I go all the way around the circle and end at 0, 1. So again, this is slightly backwards from the way that we usually parameterize this circle. What is the radius of my circle? Well, it's radius 1. But how do I know what kind of shape to expect from a parametric equation? How could I change this formula to give me something else? Now, when I'm given this kind of parametric equation, I would like to be able to know the shape that it makes before I go off to have a computer graph it for me. So for this problem specifically, I know that my x and y satisfy these equations. X is equal to sine of t, y is equal to cosine of t. But I would like to get rid of that parameter, to have an equation with just my x and y in it, no t's at all. So since I've got sines and cosines, and sine squared plus cosine squared is always equal to 1, I should be able to get rid of my t's by squaring both sides of these equations for both of them. So x squared has got to be sine squared of t. Y squared has got to be cosine squared of t. And if I add these together, x squared plus y squared equals 1. No more t's. So given the right formula, I should be able to rewrite this and have some relationship between my x's and y's written with no t's involved. I would call this process removing the parameter.